Okay, let's dive into this. Welcome to The Explainer. Today, we're taking a really fascinating look at the multi-decade evolution of the internet. I mean, it's something most of us use every single day, right? We completely take for granted the invisible digital infrastructure that just powers our modern lives. But, it wasn't always this seamless ecosystem connecting billions of devices. Not even close. We're going to trace its incredible journey, starting out as a highly classified Cold War military project, navigating through some massive technological hurdles, and finally blossoming into the global World Wide Web you and I know today. To truly understand this massive transformation, we're going to follow a clear chronological journey through 5 pivotal chapters. First, the Cold War catalyst. Second, ARPANET and the first message. Third, speaking a universal language. Fourth, the directory and global reach. And finally, number 5, entering the World Wide Web.
So, Section 1, the Cold War catalyst, solving the vulnerability problem. Let's start right at the beginning, in a world dominated by Cold War anxieties. Picture it, it's 1958, and the United States Department of Defense creates the Advanced Research Projects Agency, or ARPA. Their primary goal here was to establish technological leadership. But crucially, they needed to optimize their computing resources while creating robust, survivable communication networks. They needed a system that could withstand partial destruction, even from something as catastrophic as a nuclear strike.
And out of this super tense environment came a literally visionary idea. Back in 1962 and 1963, a computer scientist named J.C.R. Licklider started writing memos outlining what he playfully dubbed the Intergalactic Computer Network. He envisioned this globally interconnected network where absolutely anyone could immediately access data and programs from anywhere. Now keep in mind, this was a time when computers were massive, room-sized machines, which makes his foresight just staggering.
But to actually make Licklider's vision a reality, they had a major technical hurdle to overcome. Let's compare the 2 primary network models of that era. The traditional telephone network relied on something called circuit switching. This required a dedicated, continuous electronic line between the caller and the receiver. If that single line was broken, the communication just died. It was a massive vulnerability. To fix this, researchers Paul Barron and Donald Davies independently developed a theoretical model called packet switching. This new model was robust and entirely decentralized.
And this brilliantly illustrates exactly how packet switching works. Instead of sending one huge file down one vulnerable pipe, the data is chopped up into small message blocks, or packets. Each packet is then sent independently across the network, weaving through whatever paths happen to be available, and then they all reassemble really quickly at their final destination. If one pathway is destroyed, the packets literally just route around the damage. This simple but incredibly resilient concept, it became the technical foundation of the entire internet.
Okay, Section 2, ARPANET and the first message. Making the first connection. Let's move on and see how this all builds into something physical. By late 1969, those theoretical models and visionary concepts were finally being put to the test. This was the birth of the ARPANET project, which was this ambitious initiative to connect academic and scientific pilot nodes all across the United States. That initial ARPANET configuration consisted of just 4 geographically dispersed nodes: UCLA, the Stanford Research Institute, UC Santa Barbara, and the University of Utah. The host computers located at each of these facilities were all completely different systems. We're talking everything from IBMs to DECs. Connecting these totally incompatible machines was a huge collaborative academic triumph, requiring some truly groundbreaking software and hardware interfaces to pull off. So you might be wondering, what was the very first message sent across this monumental network? Well, on October 29, 1969, a student programmer at UCLA named Charlie Klein attempted to connect to the computer at the Stanford Research Institute. He typed the letter L, and the Stanford machine received it. He typed the letter O, and it was received. He typed the G for login, and boom, the entire system crashed. No way, right? So the very first word ever transmitted over what would eventually become the internet was simply LO.
Despite that slightly embarrassing initial crash, the network stabilized and quickly started to grow. Just 2 years later, in 1971, a researcher named Ray Tomlinson invented something that would change human communication forever: network email. To make it work, he actually arbitrarily chose the @ symbol from his keyboard just to separate the user's name from the host server. And it was an instant hit. Within a couple of years, email accounted for a massive 3/4 of all traffic on the ARPANET.
Moving into Section 3, speaking a universal language. The problem of incompatible computers. As we head into the 1970s and 80s, the network was definitely expanding, but a massive new challenge popped up. Other independent networks were being built, but they all used entirely different protocols. They were completely incompatible. It was essentially a digital Tower of Babel. The networks literally could not communicate with each other.
So the absolutely crucial point here is that without a common language, a truly global internet was basically impossible. Enter Vint Cerf and Bob Kahn. These guys developed a universal communication protocol suite known as TCP/IP. You can think of it like a universal translator that allowed entirely different networks to seamlessly internetwork or talk to one another. A real game changer. Tracing our timeline here, we can see the progression from that first crashed message in 1969 to the publication of the TCP/IP papers in 1974. But the truly monumental shift, that happened on January 1, 1983. Known as Flag Day, this was the exact moment ARPANET formally mandated the switch to TCP/IP. By networking all these individual networks together with one universal protocol, Flag Day effectively marks the official birth of the modern internet.
Section 4. The Directory and Global Reach. The problem of memorizing IP addresses. Okay, so with networks now finally able to talk to each other, expansion just exploded. But of course, this created yet another logistical nightmare. Back then, if you wanted to connect your computer to a new machine on the network, you actually had to call up the Stanford Research Institute office on the phone to ask for a numeric IP address from a master file they maintained. The problem? That office was closed on weekends and over the Christmas holidays.
Luckily, a researcher named Paul Magapetris brilliantly bypassed this whole holiday scheduling problem in 1983. He invented the Domain Name System, or DNS. Instead of relying on one centralized office to manually hand out numbers, DNS automated the entire process and distributed those duties across multiple servers. And, more importantly for us, it translated those clunky numerical IP addresses into the easy-to-remember names we use today, ending in extensions like .com or .edu. Now, what's really interesting about this next milestone is how it showcases the internet's rapidly expanding global footprint. Because of TCP/IP and DNS, international connections suddenly became viable. In fact, on October 12, 1988, the Tec de Monterrey University established the very first dedicated internet connection in Mexico and Latin America. Using a Microvax 2 mini-computer acting as a bridge to a Texas network, they effectively tied a massive new region into the global digital ecosystem. Which brings us to Section 5, entering the World Wide Web, making the network accessible to everyone. We've reached our final chapter. By the late 1980s, the internet had global reach, sure, but there was still a major catch. It was this highly technical, pretty clunky, entirely text-based tool operated through those old green terminal screens. It was almost exclusively restricted to academics, the military, and government researchers. To understand how it finally reached the public, we actually need to clear up a super common misconception. The internet and the World Wide Web are not the same thing. The internet is the physical infrastructure. It's the underlying global network of computers, servers, and physical cables. The World Wide Web, on the other hand, is the system of hyperlinks, web pages, and URLs that we use to actually interact with the information. Basically, the web rides on top of the internet.
The web was absolutely the missing piece of the puzzle, and it was invented between 1989 and 1990 by a British scientist named Tim Berners-Lee at the CERN Research Center in Switzerland. He developed HTML, HTTP, and the URL system, making it incredibly easy to link documents together. When the very first website went live in 1991, the internet was suddenly transformed. A couple of years later in 1993, a program called NCSA Mosaic became the first popular browser capable of displaying images right alongside text. This sparked the infamous browser wars between Netscape Navigator and Microsoft's Internet Explorer, which led straight into a mass commercialization boom. Suddenly, companies like Amazon, eBay, and Yahoo were opening the floodgates for the general public. Looking back at this decades-long journey is just truly awe-inspiring. We went from a 4-node military experiment focused on surviving the Cold War to the invention of the web that literally changed human history. But the evolution didn't stop in the 90s, did it? The new millennium brought the Web 2.0 era. This was a massive shift from read-only websites to a highly participatory social internet where users actually created the content. Social media giants like Wikipedia in 2001, Facebook in 2004, YouTube, and Twitter rapidly emerged. Then, the launch of the iPhone in 2007 ushered in the mobile era, keeping us connected anywhere at any time. As we moved into the 2010s, massive data processing and storage shifted completely to the cloud, powering streaming services like Netflix and Spotify. Everyday objects, from your smartwatch to your refrigerator and even your car, started going online through the Internet of Things. And today, we're right at the dawn of the AI revolution, with tools like ChatGPT reshaping how we search for and generate information, while Web 3.0 promises a future of decentralized networks where you actually control your own data. As this incredibly resilient, invisible ecosystem continues to weave into the fabric of billions of lives, I want to leave you with a final thought. From a simple command that crashed a room-sized computer to an intelligent global network, how will this ever-changing digital universe evolve next? Thanks for learning with us, and keep exploring.